In 2008, NASA had an intriguing question. How do spiders construct their webs in zero gravity? Therefore, they sent 2 spiders to the International Space Station. The first spider was the main participant, while the second served as a backup in case the first one didn't survive. However, things didn't go according to plan. The backup spider managed to escape from its chamber and visited its companion, resulting in a bit of a mess. They built tangled webs that interfered with each other. As if that wasn't enough, the flies that were supposed to be food for the spiders started reproducing faster than anticipated. Their larvae escaped from their container and covered the front window of the chamber. Over time, the spiders were completely hidden behind the larvae. Although this initial experiment didn't go well, one of the researchers involved in planning the spider experiment was still curious. In 2011, she got another opportunity to repeat the same experiment. This time, she sought assistance from other researchers. They decided to send a different species of spider into space and prepared 4 spiders, 2 for the ISS and 2 for Earth, allowing for result comparison. The goal was to expose the spiders to varying gravity conditions and observe their behavior. However, another twist appeared in the story. Initially, they believed they had 4 female spiders, but it turned out that 2 of them were actually males. Determining the sex of young spiders can be tricky, but fortunately, one male had already been sent to space, while the other remained on Earth, enabling valuable data collection. The second experiment proved successful. The spiders were active. They built and dismantled webs, and even without the assistance of gravity, they spun new ones. 3 cameras captured thousands of pictures, showcasing their hard work on the webs. Interestingly, it seemed that spiders created significantly more symmetrical webs in space than on Earth. The center of the webs was closer to the middle, and surprisingly, the spiders didn't always position their heads downward as they typically do on Earth. However, one significant factor made all the difference: light. When the spiders on the ISS had a source of light, they weaved asymmetrical webs, similar to those found on our home planet. Light played a crucial role in orienting the spiders in space. The chamber's lamps were attached at the top. If the lights had been positioned differently, for example on the side, it would have been challenging to observe the effect of light on the symmetry of webs in zero gravity. When the lights were turned off, the spiders rested in random orientations within their webs. Yet with the lights on, they would orient themselves away from the light source, which meant downward. Hence, in the absence of gravity, light assisted them in orientation. This discovery was unexpected, because spiders can typically build their webs in the dark and capture prey effectively, even without light. Spiders' web itself is such a cool thing wherever they are. It's like these creatures have small silk production factories inside them. Within their body, a thread is stored in the form of a highly concentrated liquid. And a regular garden spider can produce up to 7 different types of silk, each having a unique combination of proteins. Each type of silk has a different purpose. For example, one type of thread makes the web elastic, which means the web absorbs the impact when insects collide with it. Another type of silk makes the thread flexible and strong, so it's more difficult to break. Some proteins found in the silk protect it from harmful bacteria and fungi, allowing the web to last longer. They also keep the silk moist so it doesn't dry out. Wow, imagine having a home where you don't have to buy anything extra to maintain it. Spider silk is lighter than cotton and incredibly thin, up to 1,000 times thinner than human hair. But it's also insanely strong. I mean, it must be, since that's what they rely on while living their everyday life. Whether they're preying on some wandering insect or trying to resist heavy rain and wind. But you wouldn't expect it to be stronger than steel, right? Of course, in reality, you don't come across steel that thin. But if you could find a piece with the same weight as spider silk, you'd see that it has similar strength when pulled or stretched. In fact, spider silk is 5 times stronger than steel of the same thickness. Spider silk is also super stretchy, able to stretch up to 4 times its original length without breaking. Plus, it remains strong even in freezing temperatures below -40 degrees F. The most common type of spider is the orb weaver. They're masters at building those webs you keep seeing in open areas. That's where they have a better chance to catch a tasty lunch. But since they choose such spots, their webs are more prone to damage. That's why these spiders have a fascinating habit. They often rebuild their entire webs every day, even if the current web seems perfectly fine. I wish I was this dedicated to maintaining my bedroom. These spiders actually do this because they want to be prepared for the evening when they patiently wait for their potential prey to get caught in their carefully set trap. At first, this might seem like a waste of time. After all, they need to invest a significant amount of protein to produce the silk that forms their webs. But even if an orb weaver spider doesn't catch its meal overnight, it usually has enough silk proteins to dismantle its old web and build a new one for the following night. As the spider removes the old web, it consumes the silk at the same time, and by doing that, recycles the proteins it contains. If you've ever observed a spider on its web, you must have noticed how attentively it responds to even the slightest vibrations. It turns out that spider silk can be finely adjusted to different sound frequencies, unlike any other material. When a spider builds its web, it doesn't just spin the silk and leave it as it is. The spider actually makes adjustments to the silk by changing how tight or loose it is, and how different threads are connected. This way, it creates a web that can vibrate or make different kinds of sounds. The spider is like a musician tuning their guitar. This feather-legged lace weaver is called the garden center spider because it mostly enjoys humid greenhouse conditions, and it has a really cool way of catching insects. Instead of spinning sticky webs like other spiders, it uses electricity. It produces incredibly thin silk, almost at the nanoscale. And on its hind legs, this spider has special hairs that act like tiny combs. As the silk emerges from its body, the spider uses these hairs to comb and manipulate the silk. And here's where the magic happens. This process generates an electric charge. The threads of the silk are now crackling with electricity, so they come together to form little poofs that resemble fluffy balls of wool. These electrically charged poofs are a great way to trap innocent insects wandering around. When unsuspecting prey comes into contact with them, the electric charge causes the threads to cling to their bodies, making it almost impossible to get away. Female Darwin's bark spiders make gigantic webs that can stretch over rivers and lakes, which means they can reach over 80 feet across. It turns out such enormous webs are just a part of their genius plan to catch their prey. A super strong web that goes across the water like a bridge can capture large insects that gracefully fly above the water's surface, like dragonflies, and it's an impressive project that takes days to construct. These special lines go across the river and anchor the web firmly to each bank. There's no easy way out of this.
You're sitting at a coffee shop on Mars, keeping your head down, trying not to draw any attention to yourself. It's crowded, and many people are singing, dancing, and talking loudly about life on Mars. Your drink arrives, and you sip on it. So far, no one recognizes you. You're wearing a cloak with a large hoodie to cover your face and disguise yourself from everyone. Someone accidentally bumps into you and sees your face. The music stops, and now everyone is staring at you. You have nowhere to hide or run. You ignore the leering eyes and keep sipping on your beverage. An old bearded man sits in front of you, amazed to be in your presence.
"So, it's true. No one believed you'd make it," he says.
You don't reply and continue with your drink. Everyone else gathers around you. Another man speaks.
"Well, are you not going to tell us how you escaped from the clutches of the space Kraken?"
Everyone gasps in shock. No one has ever made it to tell the tale of the Kraken, except you. Your plan was to find your messenger to take you to a spaceship far away from this planet. But it's too late, now that everyone knows you're here. And the messenger fled, knowing all the attention was on you. You lay back your hoodie and explain what happened. 2 days ago. You're in your full gear, ready to make the voyage into deep space. You have a solo ship that's designed to maneuver through all the obstacles in space. You prepare the rest of the gear and fuel up. Everyone is watching you, knowing that you might not make it back. But the Kraken has been floating in space for too long, disrupting shipping containers bringing in goods. A small ship like yours can sneak past its acute sense of smell and vision. but larger ships will get destroyed. You made it your mission to find this Kraken and study it. If you learn its ways and patterns, you can figure out how to get rid of it. Everyone says their goodbyes, and you lift off. You know that it'll be a very long way to get there, possibly 3 days in the emptiness of space. You saw some quick footage of it, but no one knows exactly where it sleeps, or if it even does sleep. You put on some tunes and set your ship for cruise control. You make some notes and set the camera to document yourself while you prepare everything you need. You also have some cameras outside recording everything that moves, even thermal sensors to catch living creatures floating in space. After a few hours, you exit the safe quarters of Mars and enter into the hostile territory. There is no place to hide or anyone to help you. A few little ships like yours pass by now and then. They watch you going further to the Kraken. You notice many floating signs powered by machines warning you about the Kraken. The cameras start recording, and you begin your video journal, which is transmitting to your network at home. So far, nothing. It's quiet and dark. Hours pass, and you're just floating in the middle of nowhere. You almost feel like you want to turn around, but then you pick up something in the sensors. You see a large live object nearby. You turn off the lights and slow down your ship. You resume recording and start talking to yourself, explaining everything. The object is getting closer and closer. You move aside to avoid it and latch on to a floating rock, but you still don't see anything. Out of nowhere, you see some glowing jellyfish-like creatures flowing together in a cluster. On your thermal sensors, they appear to be large objects, but in fact, they are just little creatures. According to your studies, these creatures are some of the main foods for the Kraken, so they're probably running away from it. After a few minutes, the creatures float away, and you launch yourself out and turn the lights back on. A few more hours pass, and you still see no Kraken. Suddenly, a whoosh shakes your ship, and you're thrown slightly off course. You notice that a large object has spiked your thermal sensors and left. You keep going and check the playback settings to see if your cameras manage to catch something. You try to look carefully, but it seems like a gust of wind blew past you, which is weird because there is no wind in space. You check the thermal sensors and notice that a large object shaped like the Kraken has zipped past you. It's still around, and it has probably caught your scent. Your system's got some DNA particles and are studying them. After a while, they show that the Kraken's skin can change colors according to its surrounding. Its skin is thick and made up of some cosmic fluorescent material that is new to any creature you've ever come across. The system continues studying it. After a while, the Kraken goes off your radar and disappears. You circle back, trying to find it. People back on Mars can see the data and already have information about its size and skin quality. They even see some footage you've managed to catch. As you continue driving towards it, you open your floodlights, trying to see anything. Your cameras are still rolling. Suddenly, the Kraken changes skin color and appears right in front of you. Its large tentacles flash around, whipping nearby space debris. Its large eye that's as big as a bus looks right at you. It opens its mouth, and you see layers of sharp teeth circling like a grinder. It has a large beak that can break your ship easily. It starts flashing its colors rapidly as a way to warn you. It shoots out some liquid to move in a no-gravity space environment. It's moving towards you until it launches itself. Your ship has an auto force field for protection, but it can't sustain the powerful bite of the Kraken. After only a few seconds, the shield breaks, and your ship spirals down to another planet. You crash-landed in a swampy land. Your ship has survived, but it can't take off. The analysis of the Kraken is ready. It shows that it doesn't need oxygen to breathe, and its DNA is evolving. Now that it got a bite of your force field, it can adapt itself to create a bioforce field of a similar nature. But you crashed on a planet that is foreign to you. You put on your safety suit and observe the environment. The atmosphere is filled with nitrogen and sulfur. You get out and walk around. It has similar gravity to that of Earth. As you venture through the swamp, You start seeing little skin particles similar to those your ship has caught. The liquid below you is some foreign substance that seems to be deteriorating your suit, so you opt to hover. The trees are strange and seem to be living off the atmosphere, but there is no sign of life anywhere. Suddenly, you see a huge crater that leads to the center of the planet. You enter it and see some ships similar to yours. It seems that the Kraken knocked them off course, and they all crash-landed on this planet. Many of them seem to be intact, while others are completely obliterated. Your sensors pick up another reading. It senses another creature dwelling in the center. You try to get closer. You're doing your best to be as gentle as possible, but you feel the ground shaking below you. You duck down and try to avoid the rocks falling overhead. A large tentacle pops out of nowhere, and then another and another. It swings itself out and crawls in the open. According to your system's studies, this Kraken is 10 times larger and even looks different. It doesn't spot you, but it can sense that you're around. It starts thrashing the planet, trying to find you. It knocks your ship. You try to find a way to start it, but it's missing a piece. You find another abandoned ship and take out the part that you need and put it on your ship. Your suit has an auto repair function that allows you to fix your ship without the tools. After a few minutes, it's ready for takeoff. You power up your ship, even though it's damaged, and lift off. You manage to sneak past the Kraken. Everyone at the coffee shop is silent. Many don't believe your stories. They had stopped receiving live transmissions before you were knocked off by the space Kraken. Out of nowhere, an alarm rings and warns that the Kraken has arrived. Everyone rushes off in a panic. You hear a voice in your head. It's a bunch of gibberish, but you start getting visions of the Kraken talking to you. It knows you're here, and it's coming for you.
We interrupt this program to bring you this important message. The Earth is no longer fit for living, so you'll need to find your own new home. You immediately get the brilliant idea to apply for a job as an astronaut. You'll be able to wait over the hustle and bustle on the International Space Station until humanity finds a new home, right? The longest time a human has spent in space so far is 437 days and a few extra hours. And when I say in space, I mean the ISS, because a human being without the proper equipment in open space would only last a few seconds. The ISS is designed to support human life in space for extended periods of time. Extended, but not endless. The station gets resupplied with food, water, air, fuel, scientific equipment, and other necessities every 3 months. With no Earth or humans to send the mission, this lifeline will soon be broken. The station is a huge ship moving through space at over 17,000 miles per hour. It faces pretty harsh conditions, from radiation to micrometeoroids and huge temperature ups and downs. That's why the system regularly needs patching up. In addition to wear and tear, there are also unexpected events that can require resupply missions. In 2020, the crew discovered a leak that was causing a gradual loss of air pressure. They eventually found cracks in one of the modules. The crew managed to fix it, but it proves how important it is to have enough spare parts on board. Let's say the future humans will manage to find a way to run the station non-stop without restocking. Astronauts already grow plants in space in closed boxes with low-energy LED lights. It's not only a source of vitamins, without which humans can't survive, but a great mood booster. We'd also need more advanced closed-loop life support systems to recycle air and water efficiently. It's a system that captures carbon dioxide from the air by passing it through small beads. Then it uses steam to separate the carbon dioxide and transform it into methane and water. Water then divides back into oxygen. But even with all the possible advances, there's another problem: the health of the astronauts. They live and work in a microgravity environment, and they rely on carefully controlled life support systems. But our bodies aren't designed to live in weightlessness forever. It's like standing on your head, because the reduced gravity makes bodily fluids accumulate in the upper parts of your body. The result is a puffy red face. The gravitational force on the ISS is weaker than on Earth, so muscles don't have to work as hard and bones gradually lose their density. That's why each crew member follows a strict daily exercise routine. The heart muscle also weakens because it doesn't have to use as much effort to circulate blood throughout the body. Without Earth's protective atmosphere, astronauts are continuously exposed to cosmic rays. They are invisible waves that can cause some serious health issues. So maybe we're better off opting for Mars or the Moon for an alternative home.
The first trip intending to land on the Moon made by human mammals took 3 days, 3 hours, and 49 minutes. The Apollo 11 astronauts needed to travel some 240,000 miles to get there. Their plan was to touch down on a place on the Moon called the Sea of Tranquility because it had good visibility and the terrain there was pretty smooth. Well, up until the last few moments of the flight, when all these big craters appeared that they had to avoid, they finally landed with just 30 seconds of fuel left. Ooh, that's called cutting it close. Hey, how would you like to land in your jetliner with only 30 seconds of fuel left? So, now you know. Later that day, July 20th, 1969, Neil Armstrong stepped onto the lunar soil, saying, "That's one small step for a man, one giant leap for mankind." The astronauts were planning to sleep before the first moonwalk, but they chose to go outside earlier than scheduled. They obviously couldn't sleep. I mean, could you? Since that first visit, our lunar satellite has accumulated quite a collection of memorabilia from Earth. Let's look at some of the most important and weird stuff that humans have left on the Moon. Take footprints, for starters. I know they're not technically objects, but the marks left by Neil Armstrong and Buzz Aldrin do show that humans have been there, just in case someone or something else drops by. Since the Moon doesn't have any wind or rain, the footprints should still be relatively untouched. NASA put in a lot of effort to make sure these footprints stay protected, as well as the location of the initial Moon landing. Rules were set into place for future missions to make sure they wouldn't alter the initial site, as it's an important piece of history, kind of like a national park that you can't get to. Now, astronaut Charles Duke wanted to leave a photo of his family on the surface of the Moon. If that didn't make him the best dad ever, I don't know what would. He did take his family to the Moon, right? On the back of the picture, he wrote that he had come from Earth. He also added the date when he landed on the Moon, which was April 20th, 1972. Now, there's a good chance that his family is no longer visible in the picture today. Because of the exposure to strong solar radiation, the colors in the photo have likely faded away by now. To this day, Charles Duke remains the youngest person to visit our Moon. He was 36 years old at the time of his mission. Now, there are many flags on the surface of the Moon too, but the flags left there must have had a similar fate to Duke's photo. They're most likely discolored by now. During each lunar landing, a flag was planted as a tradition started by Apollo 11. This tradition continued with all future Apollo missions. The flags were made using metal poles to stretch the flag out so they could be seen on the Moon. But since there's no wind, they never move. Back in the 1600s, astronomer Galileo Galilei dropped two objects of different weights from the Leaning Tower of Pisa to show that the speed of the fall would be the same. In 1971, astronaut David Scott repeated the experiment on the Moon and proved Galileo's theory correct. He dropped a feather and a hammer at the same time, and as predicted, they both landed on the Moon's surface simultaneously. Fun fact, the feather came from the Air Force Academy's Falcon mascot named Baffin, with its permission, of course. These objects were both left on the lunar surface. Now, what about art pieces on the Moon? We've left some of those out there as well. The Fallen Astronaut sculpture was made by a Belgian artist and left behind by the astronauts of the Apollo 15 mission. It was a small statue requested by David Scott, the head of the mission. Scott said the statue was to memorialize the astronauts and cosmonauts who gave their lives for the advancement of space exploration. Meanwhile, astronaut Alan Shepard even played some golf on the Moon during his mission on Apollo 14. He brought a golf club head, yes, he got permission first, and attached it to a tool. Then he tried to hit two golf balls. Hey, it's hard to do in a clunky spacesuit. He did better on the second one. It's safe to say that he didn't bring the golf balls back, and they should still be there on the Moon. There's yet a message from Queen Elizabeth II there. The Monarch prepared a message which accompanied Neil and Buzz to Tranquility Base during the Apollo 11 mission. It was written on a tiny disc the size of a coin and also featured messages from over 70 other leaders from all over the world. I'll bet the printing was really small. Her message said she was proud of the astronauts and their accomplishments and hoped their journey would benefit all of humanity. The disc was then placed where Armstrong and his team first landed on the moon. After they returned, they met the Queen at Buckingham Palace. Their encounter was memorable too. Neil Armstrong almost couldn't speak to the Queen at all because he had a cold. Another astronaut named Mike Collins was so nervous about the protocol, he almost fell down the stairs. Now, some objects that exist today on the moon weren't left there on purpose. One of the most interesting moments of the Apollo 11 mission was when Neil and Buzz were getting ready to go back to Earth. They had to chuck everything they didn't need so they wouldn't be weighed down at liftoff. They also needed to store all the rock samples they had gathered from the lunar surface. This created a toss zone that archaeologists could potentially study one day. Waste like this acts as a timeline for Earth's history, but it can also help us understand what happens to objects that spend a lot of time on the surface of the moon. Now, most astronauts became pretty sentimental when strolling on the lunar dust, and who could blame them? They were thousands of miles away from their families. So that's why, in 1972, NASA astronaut Eugene Cernan wrote his daughter's initials, TDC, in the dust on the moon, and gave a speech before leaving. He said, "We leave as we came, and hopefully will return with peace and hope for all." Unfortunately, this marked the end of the Apollo lunar missions. Technically, his daughter's initials should still be there on the surface of the moon, just like all the astronauts' footprints. Can you believe it's been more than 50 years since people started exploring the moon? No worries though, as NASA's been preparing for future lunar explorations for quite some time. This new mission is called Artemis, and it aims to build some sort of settlement out there. This way, the moon can be studied in safe conditions for longer periods of time. For starters, NASA launched Orion, a spacecraft without a crew on board, to orbit the moon and come back to Earth. This was a test drive. Before NASA transports people to the moon again using newer technology, all safety measures need to be worked out and confirmed. But one day soon, Orion is going to take astronauts back to the moon. One cool thing about this spacecraft is that it comes with a launch abort system, which is meant to keep astronauts safe in case something goes bad during the launch. It also features a special service module, which is like a battery that fuels and propels Orion through space. It also supplies astronauts with water, oxygen, and power, and provides temperature control. But Artemis also looks to build a long-term human settlement on our satellite somewhere around the 2030s. However, searching for a cozy place on the moon isn't as easy as you'd think. Thankfully, NASA specialists produced an ingenious idea. They found some lava tubes on the surface of the moon, and they have pretty steady temperatures inside. The main problem with the first moon landing back in 1969 was extreme temperature fluctuations. So these caves might be the perfect solution. Not only is the temperature in there suitable for humans, but they could also help shield astronauts from cosmic rays, solar radiation, and meteorites. It's also good news that we have similar structures here on Earth. Before we get back to space, we can study them to better understand those found on the moon. Here on Earth, these holes form once the top of a stream of lava solidifies, and the molten rock inside drains away, creating this tube.
Recently, Chinese scientists discovered something interesting on the moon, an unusual crystal. Moreover, they found out that this crystal contains an element that can literally replace nuclear fuel. Let's find out more. The composition of the moon has long remained a mystery to us. Half a century has already passed since the Apollo mission. Unfortunately, we haven't traveled to the moon much since then. So it's not surprising that it's not so easy for us to study it. But recently, we've made a breakthrough in this area. In December 2020, Chinese scientists sent the Chang'e 5 probe to the moon. The mission was named after the ancient Chinese deity of the moon, Chang'e. Quite poetic, isn't it? Anyway, after the probe went to the nearest side of the moon, it spent several days digging through the surface and rocks, and then returned to Earth. In total, it collected about 4 pounds of various lunar rocks, like basalt, solidified lava, and so on. And yeah, maybe it doesn't sound too impressive, but it's actually a mini breakthrough. After all, we hadn't received any lunar samples since 1976. And these samples are very important for learning the history of our world. We've been struggling for many years to find out, for example, how the moon was born at all. Yes, there were a lot of theories, but we still couldn't find any proper evidence for any of them. But thanks to the latest missions and some computer simulations, scientists finally found out the truth. The moon was born when some random dwarf planet crashed into our Earth many millions of years ago. This dwarf planet was slightly smaller than Mars. The fragments of the Earth went into space, but some of them stayed in our orbit. Then they stuck together and formed the moon. It sounds horrifying, but in reality, the birth of the moon was the best thing to ever happen to our planet. If it weren't for this beautiful satellite, all our oceans would be small puddles. Life wouldn't have appeared on Earth at all. So this is already an amazing discovery, but that's still not all. Studying the collected rocks, scientists from the Beijing Research Institute discovered something unusual, a rare lunar crystal. Looks pretty boring, doesn't it? Just some tiny transparent monocrystal about the thickness of a human hair. We've already found such things on the moon before. These crystals were formed as a result of volcanic activity, just like some garnets on the Earth. And yep, the place where they discovered these crystals also suffered from volcanoes 1.2 billion years ago. That means that this tiny baby is over 1 billion years old. But that's not the most important thing. It's the fact that this crystal is made of a unique material, the one that we've never seen before. Researchers from the International Mineralogical Association have confirmed that such a composition can't be found anywhere on Earth. The crystal was named Chongasite, again after the same moon deity. And this is another achievement. This is the 6th previously unknown mineral that we've found on the moon and the first one found by China. Now, it has become the 3rd country in the world to make such a lunar discovery. However, this tiny crystal still wasn't the only remarkable thing they found. After studying this gem and about 140,000 other lunar particles, scientists have discovered something else. They found helium-3. Why is it so important? Because this is one of the elements that feed the sun and other stars in our universe. We tend to say stuff like, put out the sun is burning, and so on. And this is one of the reasons why many people actually think that the sun is a huge fireball. But it's not. Its burning is actually a completely different process, which is called nuclear fusion. The process itself is quite simple. During this reaction, hydrogen in the star turns into helium. But this simple process is actually one of the most violent and insane reactions in the universe. There's a real boiling broth of particles inside the sun. The hydrogen nuclei that jump and rush there are constantly repelling each other since all of them are positively charged. And so they could continue to boil and chill around without bothering anyone if it weren't for the stars. The stars turned out to be cheaters. They have such strong gravity that they basically grab billions of these little atoms and squeeze them together. Combining with each other, these atoms create new heavy elements, like the mentioned helium. And when this happens, they throw a lot of energy into space. And that's how the sun burns. At the same time, it spreads so much energy that we can't even imagine. Okay, so what is helium-3? Well, this is an element to which even the sun can say, "Whoa, dude, you should calm down." The fusion of helium-3 atoms releases even more energy than in typical nuclear fusion. And most importantly, it doesn't pollute the atmosphere with harmful things like radiation. We have very, very little helium-3 on Earth. Its prevalence in our atmosphere is about 1 in a million. And besides, it's constantly trying to escape from us back into space. Probably feels some bad vibes from us. However, scientists have recently found out that there's a place that contains a lot of this element. Yep, you guessed it, it's the moon. We think that there's more helium-3 on the moon than on Earth because of the solar winds. The sun has been hammering on the moon with its helium-3 for billions of years, so now it's all over the place. It's still not too much if you compare it, for example, with Jupiter or Saturn. But don't forget how much energy it can release. For your information, with only 25 tons of helium-3, it's possible to provide America with energy for an entire year. Now, there are 35,000 tons of it here on Earth, and more than 1 million tons on the moon. Only these sources could feed the entire US for thousands of years. So basically, in the future, helium-3 may become a new source of fuel. And it's better than nuclear fuel in basically everything. Helium-3 won't leave any harmful waste and radiation. It's more powerful and not that dangerous. In other words, this environmentally friendly and efficient energy could be a revolution for our planet. Sounds cool, huh? So, what are we waiting for? Grab the shovels, you might say. But there's a little problem here. Unfortunately, we haven't yet come up with anything as wildly strong and hot as the stars. To use helium-3, we need crazy temperatures and pressure. We need a thermonuclear reactor, and we have no idea how to build it, yet. And even if we could heat it up to such temperatures and get the needed pressure, we still don't really know how to handle helium-3 correctly. Therefore, even if we have an infinite amount of helium-3, we still won't be able to use it. But still, there's a great power behind helium-3, so it's not surprising that different countries have already started a race for nuclear resources. Now that Chang'e 5 has discovered a new helium-3 deposit on the nearest side of the moon, this race can become downright global. For example, China already plans a new lunar mission in 2024, Chang'e 6. During this mission, they want to collect the first samples from the far side of the moon. As you can see, finding this lunar crystal was very important for us. These crystals can help us find new ways to create helium-3. And if we manage to do that, humankind will enter a new era. But to do this, we still have to solve a number of problems. How to deliver a bunch of these lunar crystals to Earth, how to make them produce energy, and so on. Let's hope that in the future these issues will be resolved and we'll find a way to produce clean, safe, unlimited energy.
Hey, we landed on the moon. We sailed around the world. Romeo met Juliet. Hey, it's hard to imagine that there are creatures out there who saw it all happen. Immortal animals. Well, almost. Glass sponges are weird little creatures that sit in one place for thousands of years. From their favorite spot under the sea, they witnessed the first Europeans crossing over to the Americas. They can live up to 15,000 years. And what's even cooler is that they can control their aging process, speed it up or slow it down. They have a glass-like exoskeleton for protection. Lobsters can grow back a limb if they lose it, and they're basically immortal. They produce an unlimited number of enzymes that keeps their DNA young forever. And they just keep on growing. That means they outgrow their own shells. They have to shed their exoskeleton every now and then and upgrade to a bigger one. The largest lobster ever caught was 44 pounds off the coast of Nova Scotia. Scientists think this large lobster was around 100 years old. It was around when Edison invented the phonograph. This next creature is a mix between a jellyfish and a tree branch. Each end of the hydra has a ringed foot, and it spends its days chilling by lakes and rivers. Its tentacles grab onto tasty snacks that swim past it. So, what's the secret to its immortality? That's something everyone wants to know. The hydra has the ability to renew its stem cells. Scientists have been trying to do that for years. They can actually slow down their aging process. Now, these little sea creatures are red sea urchins. They sit on seaweed in shallow waters and are immortal. Well, we haven't been studying them long enough to know for sure. But scientists say they only grow in size, not in age. What? Well, they sort of stay like little baby urchins, but grow in size. Adult, baby urchin, okay. These little babies can reach around 100 years old, even 200. The slowest on the list? The giant tortoise. It can reach 200 years old, and one of the oldest is Jonathan. He's technically the oldest crawling land animal. He was born in 1832 and lives it up on a remote island called St. Helena. Jonathan's been through a lot. He's seen the very first American skyscraper, the Eiffel Tower. Oh yeah, he's also lived through every single World Series, starting when he was 71 years old. Now he can't see too well and he's lost his sense of smell, but he's still going strong. Back to the oceans and the Greenland shark. It's been known to be the longest living vertebrate and can live more than 400 years. Swimming around for that long in the deep, dark, cold ocean means these sharks are tough. They're able to withstand insane water pressure. Sharks are one of the only creatures today that haven't been affected too much by evolution. Many sharks have been around since the dinosaurs and haven't changed much. Scientists found out that they grow around a half an inch per year. So, with a little bit of quick math, they can easily find out the age of these tough sharks. Imagine seeing a shark that's older than the USA. This next creature is probably the most durable, indestructible, and cutest on the list. It's called a tardigrade, but scientists nickname it water bear because I guess it looks like one. But it's not exactly bear size. It has 8 legs and hands with a strange little nose. And these bizarre microscopic creatures are indestructible. They're known to live in the most extreme places on the planet. They're fine with temperatures as high as 300 and as low as minus 330. Volcanoes, frozen desert nights, they can even handle radiation and massive amounts of pressure in the deepest parts of the ocean. They can even survive the vacuum in space. No tiny little spacesuit or anything. Yeah, that would be cute enough. So far, they've survived 10 days on the outside of a spaceship, but they could probably do longer. Tardigrades might be able to outlive humans if there's some sort of worldwide catastrophe. Microscopic organisms in charge of the planet. Wonder what that would look like. Whether it's all the volcanoes erupting at once, or another ice age, or even another pesky asteroid. Tardigrades probably wouldn't even notice. Scientists are studying them to see if they can help us with some next-level biotech. Now, just for fun, here's the mayfly. This poor little insect doesn't even make it past 24 hours on average. Females and males can make it to a whopping 2 days old. Talk about living in the moment. These little flies grow in swarms and are known to have one of the shortest lifespans of any creature. But as a species, well, they've been around for hundreds of millions of years. Jellyfish have discovered the fountain of youth, and surprise, surprise, it's been inside them all along. Not inspirational poster style, but literally, it's always been inside them. Jellyfish are able to reverse their aging process whenever they want. Imagine you're swimming along and then you think to yourself, gee, I kinda wanna be 8 again. And poof, there you are. Who wouldn't want to go back to being 8? That's how jellyfish stay young and live stress-free. These brainless and boneless creatures can turn the clock back anytime they want, as long as no one bothers them. They're super chill, just floating in whatever direction the current takes them. Like, go with the flow? This creature looks like something right out of a sci-fi movie, and you could say it has sort of alien features. The giant weta outweighs a mouse and is considered one of the biggest insects out there. You find these big bugs in New Zealand. While jellyfish can reverse their aging process, some members of the weta family can come back to life. Talk about superpowers. If they get completely frozen, they start to make special proteins that stop their organs from getting ruined. After whatever amount of time they're frozen, they can be thawed out and brought back to life, like nothing ever happened. In fact, the giant weta has ears on its knees in its front legs. And because it can resurrect, it's also called the zombie bug. Planaria are flatworms that are unique. Apart from being practically immortal, they're the ultimate regeneration machines for lost body parts. If you take one of them and divide its body into 10 parts, you'll end up with 10 new planaria. You keep dividing them up, they'll keep multiplying. even though they're usually less than an inch long. Imagine if we could figure out how to do that. Would that be a way for us to live forever? Or would we end up with a totally crazy world with copies of everyone walking around? How about the world's fastest relay team, 4 identical Usain Bolts? Now, clams have been around for a really long time. Scientists have discovered that they can live up to 400 years old. These little shelled creatures are the ones that create those shiny little pearls everyone loves. A clam will go into action mode when a parasite gets inside. The clam tries to cover the parasite with a bunch of special chemicals, the same ones it uses to make the inside of its shell. That's when the magic starts to happen. When these chemicals harden up, they make a shiny, glossy pearl. The more chemicals, the bigger the pearl. Now, this long, slippery-looking creature lives deep in the caves of Europe. The olm can live up to be 100 years old. It spends its days hunting for little insects, snails, and crabs with its tiny front arms and wriggling snake-like body. Its skin is so pale that some locals even call it the human fish. Hey, wait a minute. The olm is almost blind, but it can still detect light. It just mostly does it through its skin. Like other blind animals, it has a supercharged sense of hearing and smell. It gets its distinct look from those little red gills around its neck.
So, the Terra planet's location seems to be at these coordinates. Okay, let's go to outer space to see the situation. Is it me, or is something moving? Oh no, there's too many piranhas! Oh my, there's too many of them. Oh no, 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 no! Leave me alone! Wait, no! I have to get back to the ship! We need to find shelter, now! Just a little bit more. Huh. Now we need to push off in the direction of the ship. It seems they don't see me. Come on, come on! Come on, almost! Oh no, this is the end. No, no, go away! Huh? Huh. So you guys aren't as bad as people say?
It's probably one of the worst nightmares for an astronaut, to float away to outer space without any hope to return. Just imagine slowly moving away from the International Space Station into an endless black void because of some accident, somewhere where there's absolutely nothing but a cold vacuum. Fortunately, you still have an opportunity to survive. Let's have a detailed look at the moment when this can happen. So, you're on the International Space Station. It's now at an altitude of about 250 miles in the upper layers of the atmosphere. It's important to mention that it's not just hanging out there in space. Earth's gravity is constantly pulling on the station. Not to fall, the station needs to fly around our planet at a speed of about 17,000 miles per hour. That speed is fast enough to help the station fight the planet's pull. But on the ISS, when you go into outer space, you don't feel this speed. It seems to you that you're floating in one place, watching Earth spin. But there's still a lot of space debris that moves in the opposite direction. From the point of view of a person on the ISS, the speed of these objects is incredibly fast. You put on a spacesuit. It has oxygen supplies and is equipped with a water compartment so you can drink during the mission. So, you're about to walk into space. First, you need to go through a special door called an airlock. Once you're inside, you see that there are 2 doors here. You enter and close the first door to block access to the space station's oxygen. Then you open the door leading to space. What you're about to do is called a spacewalk. There are several reasons why you might be in outer space right now. You may be conducting scientific experiments to find out how different things behave in space. Also, you can be testing new equipment, sensors, and other high-tech gizmos. Another reason might be the repair of failed parts or routine maintenance of the International Space Station. Before taking a step into the void, you attach your spacesuit to a rope connected to the body of the ship. You can also fasten small cables to your tools, such as a screwdriver or a wrench, so that you don't lose them. You push off the ship and experience a feeling similar to swimming underwater. By the way, before going out into a zero-gravity area, astronauts train inside a huge swimming pool. You hold on to the parts of the ship and head to the place that needs to be repaired. Let's say you need to tighten a small screw. One astronaut once said that any work in outer space is difficult. You're wearing a huge suit that slows down your movements and makes you clumsy. It also makes your skin itchy. The work can last up to several hours. During this time, you sweat a lot. One of the spacesuit filters may be broken. In this case, all the fluid released by your body can spread all over the suit and reach your face. Your eyes may start watering. Tears will make your vision blurry. As you see, dozens of dangers are lurking out there in open space, and there are no clear instructions on how to deal with most of them. Anyway, you're tightening the screw, but something goes wrong. The wrench jumps out of your hand, and the screw flies out of the hull of the ship. You try to catch it and accidentally push off the station. You manage to grab the screw, but your body is already flying away. You have nothing to hold on to, but you have the rope. And oh no, it's not tied to your spacesuit anymore. You've attached it incorrectly. Now you're not just flying away from the station. Your body is also spinning. The views of blue Earth and black space switch in front of your eyes. You can't stop. Fortunately, the cable is not the only safety measure. Your spacesuit is equipped with a SAFER, simplified aid for EVA rescue. This is a backpack with fuel that works like a jetpack. You activate the backpack, and it levels your flight. You stop spinning and calm down a bit. Now, you know exactly where the ISS is located. Next, you have to choose the direction manually and fly up to the station very carefully. The SAFER releases gas from small tubes, and this makes you fly forward. Using the SAFER control panel that looks similar to a joystick, you can change the direction in which the gas is released. This way, you'll steer your spacesuit. Make sure the station is in your line of sight. Press the joystick to activate the tubes, but take your time. You have to stabilize your forward movement. Pressing the wrong button can cause you to spin again, and this will reduce your chances of returning. Each astronaut spends many hours in a virtual reality simulator that makes them feel like being in outer space. So know how to control the SAFER. You're approaching the station at a slow pace. Don't let the backpack speed you up. If you start to accelerate, you need to point the tubes in the opposite direction to slow yourself down. If you fly too fast, you can crash into the station and damage the spacesuit. You've finally arrived at the ISS. You need to cling to something and move toward the airlock. You feel as if you're climbing a mountain underwater. You get to the airlock. Phew! Well, let's go back in time to the moment when you were flying away from the ISS. So, you tried to use the backpack to level your movement. You're nervous and can't calm down. You randomly press the joystick and chaotically direct the tubes in different directions. A few minutes pass. You haven't come closer to the station, and the fuel in the SAFER has run out. Now, you're even more nervous. Let's go back in time again. You float away from the ISS. Then use the SAFER and slow down the rotation speed of your body. Now you're facing the ISS. You approach the station with slow but steady thrusts. Everything is going well, but at one moment, you notice some movement. This is a small piece of metal from an old satellite. It crashes into the SAFER and slices through the backpack. Fuel starts leaking out into space. You start spinning again because of the impact. You don't understand which way you are moving. All you need now is to take a deep breath and use the remaining fuel to stop. Done. You're floating without rotating. There are no instructions and protocols that will help you get out of this situation. You're moving in outer space and can control this process. To return to the ISS, you need to push off something. Fortunately, you have time to think about what to do next. Your spacesuit has oxygen reserves that are enough for several hours. Also, you have water. You can drink it through a small rubber straw attached to the inside of your helmet neck ring. You're the first human in history who got into such a situation. But this doesn't mean there's no chance of survival. If you could throw something to the side, it'd set you in motion. For example, if you had a heavy wrench, you could throw it in the opposite direction from the ISS. This way, you'd launch yourself toward the station. But unfortunately, you have nothing to throw. You have your broken safer, but you can't remove it without another person's assistance. You enjoy the beautiful view of Earth and try to breathe as slowly as possible to save oxygen. It seems there's no chance left for you. But at this moment, other astronauts call you using the radio. They see your location and are going to save you. Your colleague is heading in your direction. She's attached securely to 2 long cables. She's going to give you one of them when she reaches you. Using the safer, the astronaut flies in your direction. She's very close. Finally, she slows down and grabs your hand. She unhooks one of the cables from her spacesuit and attaches it to yours. Using the cable, you approach the station. At this moment, a rusty bolt flies by. The main danger is that space debris can break through your spacesuit and tear the rope. You accelerate and reach the airlock, and then you open the door and dive inside. One of the most dangerous space missions has been completed. Theoretically, there's another way to save you. A spacecraft delivering food and air supplies to the ISS can pick you up and bring you back to the station. But this mission is even more difficult, as it requires a very precise route calculation. If something goes wrong, the spaceship can kick you. In this case, you will fly away at high speed. You can travel for several hours until you run out of oxygen, or a piece of space debris destroys your spacesuit. Fortunately, all astronauts are well-trained and experienced enough to avoid such accidents.
NASA has some incredible plans for the moon. For example, their next ambitious lunar program, Artemis II. They've set their sights on landing astronauts, including the first woman and the next man, on the moon by 2024. Artemis is all about building a sustainable presence on the moon. They're planning to establish a lunar gateway, a sort of space station in lunar orbit, which will serve as a jumping-off point for lunar landings. And let's not forget about the cool lunar landers. Scientists are developing the mighty Space Launch System rocket, which will launch the Orion spacecraft carrying astronauts towards the moon. Then there's the Human Landing System, a snazzy lunar lander that will gently touch down on the moon's surface, allowing astronauts to explore and conduct amazing scientific experiments. And NASA isn't going alone this time. They're teaming up with international partners, like the European Space Agency, to make this lunar dream a reality. But all these wonderful dreams might be ruined by something that seems super small and insignificant at first. Picture this: no atmosphere, no air to breathe, and suddenly, a mysterious haze and radiant beams of light appear at sunrise and sunset. It's as if the moon is putting on a celestial show. But there is a twist to this beauty. During the Apollo 17 mission in 1972, this beautiful sight made one of the NASA astronauts, Harrison Schmitt, sneeze and made his eyes water. He called it lunar hay fever. This mysterious fever affected all 12 moonwalkers. From sneezing fits to stuffy noses, those astronauts experienced symptoms as if they caught a cold. It took days for the reactions to fade away. This event led to a discovery about lunar dust and its darker side. When scientists found out about these rays, they rolled up their sleeves and delved into their origins. And here's what they discovered. Those radiant bands of light were actually caused by sunlight sneaking through layers of teeny tiny lunar dust. The dust was composed of small particles and sharp glass shards and was lurking everywhere. And it turned out that this lunar dust was a sneaky villain. It brought a whole host of problems. Astronauts who found themselves with impaired vision were just the beginning. The troublemaker went even further, damaging precious machinery and causing electronic malfunctions. It even had the audacity to corrode components and smelled like burnt gunpowder inside the spacecraft. Yikes. It clings to everything, coating surfaces like a mischievous blanket. It can clog up equipment, get into delicate machinery, and even mess with astronauts' spacesuits. In 1972, things got really hairy again. The Apollo 17 astronauts faced a nightmare. After just 22 hours of gallivanting on the lunar surface, their spacesuits suffered irreparable damage. Yes, You heard that right. Irreparable. The dust diminished astronauts' mobility, making it harder for them to move around and perform their moonwalks with grace. And no matter how hard they tried to clean it off, it clung on for dear life, leaving the spacesuits in a sorry state. So, as you can see, it poses some serious challenges for future moon missions. But our intrepid scientists aren't giving up. To solve this problem, they have to understand how lunar dust forms and why it's so darn clingy. They found out that it all begins with meteorite impacts. When these space rocks crash into the moon, they generate a fine dust that fills the air. Sometimes these impacts even cause minerals to melt, forming sharp glass shards that mix with the dust. Talk about a moon makeover. The dust is also filled with silicate, a material commonly found on volcanic planets. Silicate inhalation can cause serious lung problems for Earth's miners, so you can imagine the trouble it can cause on the moon. A recent study found that even a scoop of replica moon dust was toxic enough to destroy up to 90% of lung and brain cells exposed to it. But it gets worse. The low gravity on the moon allows those tiny particles to float around for much longer, penetrating deeper into the lungs. Imagine breathing particles 50 times smaller than a human hair for months. That's a recipe for trouble. And you see, on the moon's surface, things are a bit different than here. There are no rainstorms or strong gusts of wind to blow this dust away. There is also no atmosphere to protect the surface. So without the natural forces of wind and water erosion like we have on Earth, these dry particles stick around persistently. And to make matters more electrifying, the moon is constantly showered by radiation from the sun. This exposure gives the dust an electric charge. The solar winds create positively and negatively charged particles. The particles then buzz around, repelling each other and giving rise to those radiant bands of light that the Apollo 8 astronauts witnessed. It's like a disco party on the moon. ESA, the European Space Agency, has gathered a team of experts to study the lunar dust. They're working with simulated moon dust mined from a volcanic region in Germany to understand its behavior and effects. Engineers also need to find a way to protect future astronauts and equipment. Engineers in NASA want to create spacesuits that can survive not 1, not 10, but a whopping 100 extravehicular activities on the lunar surface. That's like spending 800 hours out there, exploring and having a blast. Besides that, NASA initiated the Breakthrough, Innovative, and Game-Changing Idea Challenge in 2021. It was open to clever university students from all over the world. These young minds put their thinking caps on and unleashed a wave of innovative solutions. For example, they proposed using special fibers that conduct electricity, inspired by fluffy chinchilla hair. Just like how chinchillas stay dust-free, these fibers would help keep the lunar dust at bay. A furry friend lending a helping paw, isn't that adorable? Another bright idea involved an electrically charged brush activated by UV radiation. It's like a magical wand that zaps away the dust with a flick. Abracadabra, lunar dust be gone. And let's not forget the fabric inspired by clever insects. These insects have pollen-collecting structures that repel unwanted dust. So our ingenious students thought, why not mimic that? They designed a fabric with similar properties, creating a shield against the sneaky lunar particles. What's remarkable about these ideas is that they all use the power of charge to fight the dust. They cleverly repel it from the spacesuits, keeping them clean and protected. And even though all these ideas sound pretty great, scientists in NASA unleashed another, even better solution: carbon nanotubes. It's a great way to revolutionize spacesuit fabric. What makes these carbon nanotubes so special? Well, they possess some amazing superpowers. First off, they're superconductive, meaning they can carry electricity like nobody's business. It's like having a lightning bolt trapped inside a microscopic tube. Not only that, but these carbon nanotubes are tougher than the toughest meteors. They have the strength to withstand the harsh lunar environment, where even a speck of dust can cause trouble. Imagine having a suit made of a material that's stronger than Superman's cape. So, NASA's scientists decided to weave these extraordinary carbon nanotubes into the spacesuit fabric. The electrodes were carefully integrated into the outer layer of the fabric, making it a force to be reckoned with. But how do they banish the lunar dust? Well, here comes electrifying science again. When activated by a special alternating current, the electrodes create powerful electric fields. These fields work like magnets, repelling both charged and uncharged dust particles away from the spacesuit. Picture this like a dance party, where the dust particles are the uninvited guests, and the electric fields are the bouncers, swiftly escorting them out. Thanks to this technology, lunar dust doesn't stand a chance against our astronauts. Also on the bright side, the lunar soil can be used to make bricks for shelters. It can also help extract oxygen for astronauts to survive on the moon for long periods of time. When life gives you lemons, make a lemonade, right? So, let's cheer on our NASA Dream Team as they embark on this epic lunar quest. Let's hope that they succeed in their findings, and the next moon mission won't be a big problem. Stay tuned.
Traveling at about 17,000 miles per hour, 250 miles above the Earth, astronauts watch 16 sunrises and sunsets every day while floating around in a box with a handful of people they depend on for survival. Whether humans should set off to other worlds beyond Earth or not, one of the most compelling drawbacks is this: our bodies don't like it. Few people know this better than the NASA astronaut who spent nearly a year on the International Space Station from 2015 to 2016, Scott Kelly. Like other astronauts, Mr. Kelly served as a test subject in the study of space travel's effects on the human body. Unlike other astronauts, Mr. Kelly has an identical twin, Mark, who is an astronaut himself. This gave researchers an uncommon opportunity to monitor the two brothers as they lived in two very different environments, one on Earth and the other 250 miles above it. When the astronaut went into space and his slightly older twin brother Mark stayed on Earth, the age gap between them increased thanks to his time in orbit. And it's all down to Einstein's theory of relativity. What it suggests is that time moves more slowly for objects in motion than it does for a stationary observer. It also moves more slowly the closer you are to a gravitational mass like Earth. In other words, we're not all experiencing time at the same rate. The faster you move and accelerate, the more time slows down. And because Mr. Kelly has been zooming up to and down from space and orbiting the planet at around 17,500 miles per hour, his brother Mark has lived through 0.005 extra seconds. The brothers were born 6 seconds apart back in 1964, and now that gap is 6.005 seconds. This warping of time is known as time dilation, and the Kelly brothers qualify for both aspects of it: how fast they've been moving in relation to one another and how close they are to a big object, which is Earth. So, depending on our position and speed, time can appear to move faster or slower to us relative to others in a different part of space-time. And for astronauts on the International Space Station, that means they get to age just a tiny bit slower than people on Earth. That doesn't mean you could spend your life in a basement just to outlive the rest of us here on the surface. The effect isn't noticeable on such a small scale. If you became a basement hermit, then across your entire lifetime, you'd only age a fraction of a second slower than everyone else above ground. But your brain might freeze when you think about this. A watch strapped to your ankle will eventually fall behind one strapped to your wrist. Your head technically ages more quickly than your feet. Time passes faster for people living on a mountain than those living at sea level. The classic example for this is the twin scenario. One twin blasts off in a spaceship, traveling close to the speed of light, and the other stays behind on Earth. When the space-traveling twin returns to Earth, she's only aged a couple of years. But she's shocked to find that her Earthbound sister has aged over a decade. Of course, no one has performed that experiment in real life, but there's evidence that it's real. When scientists launched an atomic clock into orbit and back, while keeping an identical clock here on Earth, it returned running ever so slightly behind the Earthbound clock. Then time gets even more complicated, because time dilation can happen anytime. A good way to think about it is to consider the astronauts living on the International Space Station. They're floating about 260 miles above where Earth's gravitational pull is weaker than it is at the surface. That means time should speed up for them relative to the people on the ground. But the space station is also whizzing around Earth at about nearly 5 miles per second. That means time should also slow down for the astronauts relative to people on the surface. But the reality is that Mark, the brother who's aged a few milliseconds longer, could end up better off in the long run if Mr. Kelly's extended time in space causes his body to deteriorate faster. 10 science teams in NASA's twin study examined the brothers' astronauts before, during, and after the astronauts' 340 days in space. The teams studied each twin's bodily functions, they ran memory tests, and they examined the men's genes, looking what differences might be due to space travel. They confirmed that lengthy space travel stresses the human body in many ways. Space living can change genes and send the immune system into overdrive. It can dull mind and memory. Most changes that the astronaut experienced in space reversed once he returned to Earth, but not everything. The researchers tested him again after 6 months back on land. Roughly 91% of the genes that had changed activity in space were now back to normal. The rest stayed in space mode. His immune system, for instance, remained on high alert. DNA repair genes were still overly active, and some of his chromosomes were still topsy-turvy. What's more, the astronaut's mental abilities had declined from pre-flight levels. He was slower and less accurate on short-term memory and logic tests. It's unclear whether these results are definitely from spaceflight. That's partly because the observations are from only one person. But one thing is sure, time is relative. Think of it this way. If a clock is stationary and you are traveling at a very high speed, you happen to pass by this clock and have a glimpse at it, you'll see that it's running slowly, or maybe it's completely static. This is because the speed at which the mechanical functions of the clock are working slower than you. What you see is the time in the past, while you have already skipped that second and are in the future. During this experiment of high-speed traveling, you haven't aged at all, because all the processes in your body are working at the same speed as you. After a certain age, your body starts to deteriorate, which eventually leads to a state when it stops functioning. This aging phenomenon, especially in humans, is caused by a protein structure in the cells called telomeres. These structures protect our cells from deteriorating, but with each cell replication, these telomeres start to lose strength, which is called telomere length. If the telomere length shortens to a certain extent, the cell becomes vulnerable to diseases. We can say that telomeres are the natural countdown timers in our bodies, which determine when we will expire. The telomere length can be affected by external factors like stress, which accelerates our timer. The twin study experiment by NASA included documenting the changes in telomere length of both brothers. The telomere length of the space brother increased while he was aboard the International Space Station. Before the mission, both brothers had nearly the same telomere lengths, meaning if we ignore issues like mental stress, both brothers should live roughly an equal age. But while the space brother was orbiting the Earth, he had almost 14.5% longer telomere length. The space brother was a few years younger than his ground brother biologically. Because the telomere length of the space brother resumed to normal when he came back to Earth, it took almost 190 days after return for the telomere length to restore to expected. The blood samples from the International Space Station were sent back to Earth for processing. This means the blood wasn't traveling at the speed of the ISS anymore. Also, the space-time paradox states that the space brother should be younger upon return. But the telomere length restored to its original state before the mission. The space brother was again the same age as his ground brother. A lack of gravity is the main cause for these intense changes in aging. Gravity plays an immense role in the majority of our bodily systems. Take the muscles, for example. Older people's muscles tend to shrink and decline as they age and become less mobile. Astronauts' muscles react in a similar way because they are barely used. That's why astronauts staying in space for extended periods of time use special exercise machines to help reduce this effect. A similar process takes place in the bones. After a certain age, people on Earth start to lose mass in their bones, typically at a rate of about 1 to 2% a year. But in space, those people lose bone mass at a greatly accelerated rate, as much as 1 to 2% a month. Because the astronauts' bodies don't need to support their weight, the bones begin to decrease production of new bone material and increase the amount of old bone absorption. Luckily, their skeletal systems usually return to normal once they've spent some time back on our blue planet. If the space brother was shielded from all harms of space, like radiations, while orbiting the ISS, then he would have lived longer than his ground brother. Even though they're saving 0.005 seconds, astronauts still experience some of the symptoms of a drawn-out aging process. So the next time you find yourself wishing the weekend would last longer, stay low to the ground and move really fast. It won't feel like your weekend got any longer, but technically, you may gain a teeny tiny fraction of a second. You won't need to go to space for this little experiment. It's dark outside, almost 2 a.m. You go outside and look at the sky, and here it is, bright, full moon. You might think you know a lot about Earth's natural satellite, but let me ask you this. How did it form? The answer is, nobody knows. But of course, there are theories. The most popular one, called the giant impact theory, claims that the moon formed during a collision between Earth and another planet. This planet must have been smaller than ours, the size of Mars, and the collision itself probably happened around 4.5 billion years ago. Another theory, called the capture theory, claims that the moon used to be an asteroid or some other wandering body. It formed somewhere else in the solar system. When it was passing by Earth, it got caught by our planet's gravity. But here is one catch. Our planet and the moon have remarkable isotopic and chemical similarities. So, they must have a linked history, which means the moon couldn't have been created elsewhere. Other experts think that at some point in the past, Earth was spinning so fast that some of its material broke away. It soon started to orbit our planet. That's how the moon appeared in the sky. But again, there's one problem. In this case, the proportion and type of minerals on the moon would have to be the same as on Earth. But there are slight differences. The moon is richer in materials that form very fast at high temperatures. There's one more theory, and it's probably the least exciting. It claims that Earth's natural satellite could simply appear along with Earth during our planet's formation. Duh! But these days, a more urgent question keeps astronomers busy. Is the moon really Earth's satellite? Or are these two twin planets? The moon is big compared to our planet, about 1/4 of Earth's size. That's why some experts refer to our planetary system as a double planet. But how correct is that? If we want to figure it out, we need to give the definition to the word planet. According to the International Astronomical Union, a planet is a space body that orbits the Sun, is massive enough to have a nearly round shape thanks to its gravity, and has cleared the region around its orbit. Now, what about a satellite? It's an object in space that orbits around a larger celestial body. If we take the system Earth, the Moon, its center of gravity, called a barycenter, is inside the Earth. That's why at the moment we can't say that we live in a twin planet system. According to this definition, the Moon is the satellite of our planet. Now, let's get back to the past, like 3 or 4 billion years ago. Even though the Moon wasn't a planet, it most likely had a full-fledged atmosphere. It formed at times when powerful volcanic eruptions were rocking our satellite. Gases spread all over the Moon's surface, and it happened so fast that they didn't have enough time to escape into space. At that time, the lunar surface was covered with basins filled with volcanic basalt. Just imagine ginormous plumes of magma hurtling high into the air, falling to the ground and creating lava flows. That's how the basalt basins appeared on the surface of the Moon. At one point, scientists got their hands on samples brought from the Moon. They found out that lava flows there contained not only carbon monoxide and sulfur, but also the building blocks of water. Thanks to these samples, researchers managed to calculate the amount of gas that rose and formed the atmosphere. It became the thickest around 3.5 billion years ago and existed for about 70 million years. After that, poof, the atmosphere was lost in space. But the coolest thing? When the Moon did have an atmosphere, the satellite was 3 to 10 times closer to our planet. One computer simulation even suggests the Moon was probably up to 19 times closer than it is now. The distance between it and our planet could be 18,600 miles, while these days our satellite is around 240,000 miles away. That's why the Moon looked much, much bigger in the sky. Unfortunately, at that time, not even dinos were around to admire the view.
These days, the atmosphere of the moon is almost non-existent, and that's why the satellite can't protect itself from meteorites. The surface of the moon is dotted with craters. For comparison, there are about 190 identified impact craters on our planet. Many of them are hidden by vegetation or covered with water. But if we speak about the moon, the number is so much greater, several million, and around 5,000 of them are more than 12 miles across. And since the moon is less seismically active than Earth, these craters and other ancient formations stay in perfect condition for centuries. When you look at the moon, it's the brightest object in the night sky. But in reality, its surface is dark because the reflectance of our natural satellite is just a bit higher than that of asphalt. You might know that the moon's gravitational pull causes tides on our planet, making the oceans bulge out on both the side closest to the moon and the one farthest from the satellite. But that's not all. The moon also slows down Earth's rotation. This phenomenon is known as tidal braking. It increases the length of a day on Earth by a bit more than 2 milliseconds per 100 years. The moon is also moving away from Earth at the same rate at which your fingernails grow. That's about 1.5 inches per year. If one day the moon floats away into space, our planet will have to live through tough times. Without the stabilizing pull of the moon's gravity, Earth's tilt would start changing wildly, from no tilt at all, meaning no seasons, to a large tilt, resulting in extreme weather. Even though the moon's surface is mostly dormant, Earth's natural satellite still experiences moonquakes. One theory suggests that they may be happening because the moon is shrinking as its insides are cooling. Scientists say that the moon has become around 150 feet skinnier than it used to be several hundred million years ago. To help you understand it, picture a grape turning into a raisin. It wrinkles while shrinking. The same is happening to the moon. It's shrinking and it's wrinkling. But unlike the grape, the moon doesn't have flexible skin. Its surface is hard and brittle, so as the moon gets smaller, the crust cracks and breaks, and its sections get pushed over neighboring parts. Want to know another cool thing about the moon? A recent study claims that it has a tail, and every month it wraps around our planet like a scarf. This slender tail is made up of millions of atoms of sodium, and our planet regularly travels directly through it. Meteor strikes blast these sodium atoms out of the moon's surface and further into space. For several days every month, the moon remains between the sun and our planet. That's when Earth's gravity picks that sodium tail. Our planet drags it into a long stripe that wraps around its atmosphere. This lunar tail is totally harmless. It's also invisible to the human eye, 50 times dimmer than what you can perceive. But during those rare days, high-powered telescopes can spot its faint yellowish glow in the sky. The tail looks like a gleaming spot that's 5 times the full moon's diameter. And the spiciest fact for you, 2 or 3 years ago, an asteroid was pulled into Earth's orbit and started to travel around the planet. Even though it was no larger than an average car, it was still a big deal. Out of more than 1 million asteroids astronomers know about, it was only the second one to orbit our planet, called 2020 CD3. It was our temporary mini-moon. It didn't stay with Earth for long, though. The asteroid followed a random orbit and slowly drifted away. Temporarily captured objects such as 2020 CD3 are rare. They need to have a specific direction and speed to be caught by Earth's gravitational pull. Otherwise, they either crash into the planet or fly in another direction.